Hey everyone, Larry Wynn at Summit Imaging, an ultrasound and mammography equipment support organization. And today we want to bring you another video to educate you on what's going on in the market, specifically ultrasound transducer repairs, and giving you information to arm yourself to maximize your uptime and mitigate some risk on this really critical equipment that you all use out there. And what we discussed in the past is really low quality and counterfeit parts being used to quote unquote repair your equipment out there. And we're advocates of very high quality equipment to preserve the safety and performance of the equipment. And what we've been seeing in some other standard transducers that have these knockoff parts in them, we're seeing them now being used in some more critical imaging assets such as TEE probes. And why this is alarming for us, and we wanted to make a video to educate you, is that these are intercavity transducers and they are actually going down a patient's esophagus and getting an image of the heart that is crystal clear. There's no ribs in the way to obstruct the image. And really critical, because the patient's under anesthesia and a really intensive exam and a study that is performed with this piece of equipment. So there lies some things that are really important to protect the patient, number one, and also protect healthcare facilities as well. So we have two examples. On this side is really a non-OEM counterfeit parts, whatever we want to call it, but there's low quality stuff in this probe that we'll tell you about, and we can kind of compare it to an OEM. So let's kind of talk about really the critical things that we're seeing, and this is an actual customer asset that came in on what's going on and how it impacts you. So first and foremost, we have a strain relief, and you can see, and we're going to do a close-up of this, that this strain relief is already torn. And this is actually a premature failure. It's discoloring, and when you actually assess the material and compare it to what an OEM strain relief looks like, it's definitely not the same. And so by virtue of having different physical properties and it being damaged so prematurely, and you look at this, I can actually now change where the cable is bending, and now because the strain relief is torn and shortened, it actually changes the pressure point and increases the pressure and the strain of all the micro lines that are inside the cable. How is that a problem? Well, that's a problem because you're going to see noise. It usually manifests itself in CW noise first. And when these lines inside are chafing against each other to a higher degree than what the original strain relief was designed for, then you start actually getting premature failure and really shortening that mean time between failure on these assets. Therefore, and so this is actually on both sides, on the handle and on the connector side, and we just found that odd that those have been installed on such a valuable piece of equipment. The second thing is, as we graduate up the transducer, we'll do a zoom in of here, but we actually have non-OEM lines that aren't even close to the specifications of the original lines. Now, these non-OEM lines, they're thicker, they're more rigid, they're not as flexible, and therefore the expected life of that cable assembly inside those low quality strain reliefs, it only compounds the problem worse for an end user. So that's going to further decrease your uptime because this is going to fail again. And whereas you look at these orange lines that are in an OEM transducer, here, those are the correct lines that should be inside this equipment. So these are wonderful lines that have been designed to be inside that cable, and they provide all the flexibility. And in addition of that flexibility, which gives you longevity, reliability, extending that mean time between failure, it also has a correct strain relief to do the exact same thing. And so what we're seeing is two low quality parts installed on a high value piece of equipment that's critical for patient scans, actually going to decrease the useful life of this piece of equipment. Now the other two things we want to chat about today is, number one, the lens as well. this lens, we'll show you examples of how this lens is really interfering with the image quality of the transducer. So if you look at the image that we're showing you right now, it's extraordinarily bright and it's lacking some of that, what we're seeing, and this is just really an image quality assessment that it's too bright, and we are assuming that there's no filters in there. And there are some materials inside that help with the image quality, and it looks to be that is missing. We haven't pulled back the lens to fully assess because the customer wanted us to keep that intact for right now for their own educational purposes internally. But that is an issue that you can see on the screen now. The final thing we wanted to show you is that in assessing and evaluating this transducer with the customer's permission to disassemble it to the level that we have, is that if you look at this, the top portion of this TEE probe, the head and the bending section here, should be properly attached to this insertion tube. And now, this was never attached, and I should not be able to spin this top portion from the insertion tube. Why is that really important? Well, for the physical properties of this part of the transducer, it's going to overstretch the bending rubber, and it's going to prematurely make the bending rubber fail because it's not designed to twist, it's designed to bend. And the other piece that's more of a clinical issue and an image quality problem is that every time this twists, that's going to cause CW noise on the screen. So as this is being moved around inside the patient to get a great image, you're going to be seeing this background CW noise coming in and out by virtue of this not properly being grounded and introducing noise of metal sliding on metal, and these are extraordinarily sensitive. It's going to catch that. So we don't want a misdiagnosis because this isn't properly attached, and in our opinion is a very basic repair that should have been done in the first place. But as you can see, this is moving around, it's going to cause noise and therefore compromise the efficiency or accuracy of the study that this probe is being used for. So at the end of the day, we're advocates of quality. We really want high quality products entering the healthcare facilities because at the end of the day, the patients are what matter most. We have to help the patients and make sure that all the equipment that's entering healthcare facilities to serve them is doing the job the way they're supposed to do it. And as you can see, there's some diagnostic issues with image quality, but at the same time, if you're looking at patient access, the equipment's got to be up to scan the patient. If it's down, the costs associated with that of, rescheduling patients, readmission from inaccurate diagnosis, all of these things are so costly that it really behooves all of us in the industry to do it right. Because when it's done right, efficiency goes up for the entire industry, and patients are then enjoying better health care. And so we hope you enjoyed the education that we provided today. And if you have any questions on what's going on in these transducers, we're always more than happy to help. Thank you so much for joining us in our video, and talk to you next time. Thanks.